Okay. So this is just the, I don't know, yung module natin. So again, by Shvorinov's rule, yung time kasi of solidification is directly proportional dun sa volume to surface area ratio. So again, itong volume to surface area ratio is a very, I don't know, parang important concept kasi dito halos lahat nag-base yung calculations natin when it comes to riser design. So the concept is that the surface area is more related to the because the surface area is in contact with our mold wall, then etong surface area na to would be an index of how fast the setup can draw heat away from the liquid melt. Okay? Tapos si volume is an index of the heat content of your object, no? So if you have a higher volume to surface area ratio, meaning yung volume mo is for the same volume, maliit yung surface area na naka-cover ng isang object na yon, then therefore mataas yung magiging solidification time niya or mas mabagal siya mag-solidify kumbaga. Okay? Nagme-make sense ba yun? This makes a lot of sense, no? Kasi again, kung mataas yung heat content ng material mo, yung object mo per se, and you have a small surface area, then yung malaking heat content na yun, hindi agad-agad magko-cool down dahil konti lang yung quote-unquote cold walls uh, na in contact doon sa liquid melt natin. Okay? As compared to a smaller volume to surface area ratio, no? Which is, ito yung mga objects na ang tawag sa kanila is yung rangy type of castings, no? So ito yung tinatawag na rangy casting. So rangy castings, sometimes known as your plate-like castings, no? So if plate-like siya, this is where you have a small for a particular volume, mataas yung surface area na meron siya. So a good example of this is yung mga plates, and one of the siguro kung gamer kayo, medyo common sa inyo to. Are you familiar with heat sinks? Heat sink yung nilalagay natin sa CPU natin. So heatsink has a design usually para siyang ano no, kunwari may core tapos may parang spider na ganyan, mga fins siya. So if anyone is familiar with heatsink and you can search this, etong mga fins na to is thin na plates, no? Parang ganyan sila. So I hope you can imagine ito. So see, it's a meron tayong, if you see it from the top view, ganyan siya. May core siya, and attached to the core are fins of aluminum metal, no? So if you can see, etong type of design na to has a very small volume to surface area ratio. So for a small volume, mataas yung surface area niya. And that is why ito yung reason kung bakit si heat sinks are very effective in cooling down your CPU, no? Kasi mataas yung surface area niya, so malaki yung in contact doon sa metal with the outside environment, so malaki yung drawing of yung kinetics ng heat transfer niya from the metal heatsink outside to the environment. Okay? Pero syempre, when it comes to risers, no, ang goal kasi ng riser is not to cool faster, no? Ang goal natin is ito dapat yung slowest na magko-cool. Okay? So it makes sense, no, kasi if you think about it, kung ang riser, ang primary goal ng riser, as we've learned from the previous modules, is that siya dapat yung magiging reservoir mo para ma-prevent yung shrinkage defects. Tama? So from the previous modules, you've learned that kunwari may casting tayong ganito. If it starts off kunwari ganyan, ito yung liquid melt, when it cools down, yung likely na end niya na itsura is something that looks like this. So meron tayong shrinkage dito sa part na to. And the shrinkage occurs because again, yung metal kasi natin has a higher density than the liquid melt. So meaning smaller yung volume niya. Tama, for the same amount of material, smaller yung volume na ino-occupy niya. So that shrinkage will cause a defect in your material, which we do not want, no? So para ma-alleviate to, gagawin natin is, for example, if this is your metal, gagawin natin, lalagay tayo ng sacrificial na riser dito. Okay, so this riser will feed metal into the liquid metal into the final casting. So ang mangyayari is we'll have something that looks like parang ganyan. And let me. So magiging ganyan siya. Tapos i-cut off na lang siya after casting. So what this does is instead of yung shrinkage defect or instead of yung shrinkage defect will manifest in the final casting, yung final casting natin is buo siya, tapos yung shrinkage defect natin nandun lang sa riser, which is okay, no? Kasi yung riser naman, sacrificial lang naman siya. So it's a reservoir meant to feed liquid metal as the casting solidifies. Okay? Malinaw ba yun? Yung concept ng risers? Okay. Sir, wala po akong pulang dot na nakikita. Anong pulang dot? Doon sa ano? Dito sa Google. Actually, nagre-record din kasi ako sa OBS, so kahit wala, nare-record pa rin siya. Right? So, again, ang goal ng riser is to be a sacrificial reservoir for to prevent the shrinkage defects doon sa final casting natin. Okay? So with that said, if it is a sacrificial reservoir that is meant to feed liquid metal, then it makes sense na dapat siya yung last to solidify. No? So it should have a high volume to surface area ratio. Dapat mataas tong volume to surface area ratio na to. Itong part na to, mataas siya para yung overall solidification time niya tataas rin. And again, ang ano natin, the conclusion is that for metals, for common shapes, no, the volume to surface area ratio for spheres is the highest, no? But again, in practical kasi si sphere, kasi when we just try to imagine, no, kunwari meron tayong if we have, for example, a casting na ganyan, a square casting, tapos lalagyan natin ng spherical riser na kunwari ganyan. So this is very difficult, no, because we have what we call as undercuts dito. So how will you remove the, kunwari, if we have a cope and drag na type of casting, paano mo remove yung pattern mo if you have an undercut dito? So yung undercut na to, siyempre mababasag tong part na to kasi pag remove mo ng pattern, matatanggal tong buong part na to dito. So that is what we call as undercuts, no? And in casting, usually ayaw natin ng undercuts or impossible mag-cast ng undercuts. Unless, of course, yung pattern na gagawin mo is something like yung mga lost foam, kunwari na pwede siyang ipa-evaporate lang, or lost wax, which is pwedeng i-melt mo lang. Okay? So, very difficult si sphere to work with. So, ang next best choice is actually si cylinder. So, next best choice is the cylinder. So, kaya si cylinder ang common na ginagamit for risers, no? Sometimes, if you look at yung mga backyard casting lang, no, minsan, tinatamad na kasi yung mga tao na gumamit ng cylinders or gumawa ng cylindrical risers. Pwedeng ang gamitin nila is bars lang. So, you could see some designs wherein kung ito yung casting nila, yung riser nila is actually just also a bar na parang ganyan. Which is, for smaller projects, no, this is perfectly fine lang. Gumamit ka ng bar type of riser. Pero as much as possible, gusto natin cylindrical siya para mas mataas yung volume to surface area niya, which means mas mataas yung magiging solidification time niya. Okay? So, the first method for solving the riser size is known as your Keynes method, no? So Keynes method involves an empirical equation, and I'll show the empirical equation here now. So it takes into account the freezing ratio and the relative volume. Okay, so the freezing ratio is just equal to freezing ratio is equal to the surface over volume ng riser over ng casting, I'll just say C, no? Ng casting over the riser. Okay? So another variation of this, which maybe mas madali sa inyo naalahanin, no? Is yung baliktad, yung gagamitin natin yung same notation as the Shmorinov, which is volume to surface area ratios. Pero kung volume to surface area ratios, if we rearrange that, this becomes riser na yung nasa taas, volume to surface area ratio ng casting. And minsan mas gusto ko to, no, kasi it's analogous to the relative volume, which is just the volume of the riser over volume of the casting. So parehas sila na riser yung taas, casting yung baba. So dito riser taas, casting yung baba. And bukod doon, mas maalala ko pa siya kasi same sila ng sa Shmorinov's rule, no, which is volume to surface area ratio. Okay, so but it all depends on you guys, no. So pwede naman ito yung gamitin nyo. You should have the same na, or you should arrive at the same na conclusions. So. Okay, so the empirical formula na discover ni Caine is that si freezing ratio daw is equal to a constant A over RV, which is the relative volume, minus B plus C. Okay, so where A is just the freezing characteristic na constant, B is the liquid solid solidification contraction na constant, while C is the relative freezing rate of the riser versus that of the casting. Okay, so there are textbooks that gives you some of the JB Caine constants, no? And these are just some of the common metals. Ito yung mga A, B, and C constants nila. And when we plot this freezing ratio versus relative volume, we get a graph that looks like we get this type of graph now. So what's interesting about this graph class now is etong curve na to, this curve is actually the yung empirical equation na curve. Okay? So what the curve means is that anything to the right of the curve will produce a solid casting. Anything to the right of the curve will produce a solid casting, and anything to the left of the curve will produce shrinkages. Okay? So, so ang goal natin is to have kunwari, meron tayong configuration na ang relative volume niya is 1.2. So, sa ginawa natin sa casting design na ginawa natin, relative volume natin is 1.2. Tapos, kunwari, ang freezing ratio niya is sorry, baliktad, no? Tama pala. And the freezing ratio is kasi X kasi si freezing ratio, Y si relative volume, no? Okay? So, the freezing ratio, kunwari, ang na-compute nating freezing ratio is 1.6. So, if we plot that, we see that it is well inside this region, no? So, sure tayo na this type of configuration will produce a solid casting. Tapos, kunwari 0.6, tapos 1.1 yung freezing ratio, then we are sure na magkakaroon siya ng shrinkage. So it becomes therefore na itong line na to is a sort of threshold, no? So siya yung threshold kung saan magkakaroon ka ng solid casting versus a casting with shrinkage defects. Okay? So let's try this sample problem here. So kunwari lang meron tayong steel casting ng 25 by 25 by 5 centimeter bar, and we assume na ang gusto nating HD ratio ng riser natin is 1. So the common HD ratio na ginagamit is from 1, yung HD ratio natin should be 1 to 1.5 to. So these are yung tinatawag na compact or stout risers, no? Anything larger than this is a tall riser, no? And tall risers have lower volume to surface area ratios as compared to your short risers. Okay? So ang gagawin natin dito is what we do is ito yung meron tayong object natin, no? And let me just create a new document. So meron daw tayong 25. Casting natin is something like this. And ito yung ano niya. Dimensions niya. Dimension is 25 by 25 by 5. Okay? So if I were to draw it, mas ano lang, it will look something like ganyan siya. 25 by 25 by 5. And this is more of a plate rather, no? The way we determine if it's a plate or a bar is tingnan natin yung width over ano niya, no? Yung width over the thickness. If it's greater than 3, then this is considered as a plate. Pero if it's less than or equal to 3, then it's a bar. Okay, so we have 5. This is definitely greater than 3, and therefore ito siya, this is considered as a plate, no? Pero for this for JB Caine, kahit hindi natin pansinin muna yung geometry, no? When we go to NRL method, dun natin makikita yung effect ng pagiging plate at pagiging bar niya. Okay? So we have a 25 by 25 by 5 na geometry, and we can compute for the freezing ratio nito, no? So the freezing ratio, and natin to. So the problem states that for simplicity, no, ang gagawin natin is we have a side riser such that its entire surface area contributes to the heat transfer or cooling. So this is important class now, because when we talk about the freezing ratio and yung volume to surface area ratio, we are talking about cold walls, no? So for example, if you have a top riser is something that is a riser that is placed on top of the casting. That's why hence the name top riser, no? So if you have something like this is an example of a top riser, no? Notice how for top risers, itong bottom part na to, itong below, is in contact with your casting. So therefore, ito siya, this is not a surface that has a cold wall. Tama? Again, ang main concept dito is dapat meron tayong cold wall para makapag-draw out tayo ng heat. Okay? So in this case, ang active lang na surface area na ika-count natin is itong part na to, tsaka yung top half. Tama? Because it's exposed to kung open riser siya, then it's exposed to the air, which is also considered as a quote-unquote cold wall, no? Or kung closed riser siya or blind riser, then it is also in contact with the wall. Pero dito sa bottom part, it's in contact with liquid metal. So if it's in contact with liquid metal, then it does not actually contribute to the heat transfer effect, no? So kaya dapat ibabawas mo yun. So I think for now, let's do something simple lang muna, no? So hindi muna natin iisipin yung deductions in the surface area. No? So ang iisipin lang natin muna is we'll consider it as a side riser lang. No? So a side riser, and I'll show you the benefits of the different types of riser later on. No? Pero a side riser is basically yung riser mo is placed to the side of the casting, tapos i-feed mo lang siya through a channel. Okay, so in this case, ito yung riser mo, mag-feed siya papunta dyan. So for this particular setting, mangyari is all of the surface area dito sa riser na to has a contributory effect doon sa heat transfer ng ano natin. So wala tayong ibabawas na surface area. Okay? So for this case, gagawin natin is isa-set up lang natin yung equation, no? So we know the freezing ratio is just surface area over volume ng casting, tapos over the surface area over volume ng riser. Tapos ito, this is the relative volume is just the volume of the riser versus over the volume of the casting. And itong volume of the riser, and itong volume of the riser is exactly what we are looking for, no? So what we do is, since we know the D over H ratio, then we just input all of the values dito and express it as one term. So either we can express it as a D term, or pwede rin express natin as an H term. Or pwede rin express natin as an R term, no? Because R is just equal to D over R. D over 2, I mean. D over 2 is equal to R. Okay, so ito, the surface area of the riser is just 2 pi r h plus 2 pi r squared. So itong 2 pi r squared are the two circular na basal na ano, no, na areas. Tapos ito yung nasa parang transverse na area. Okay? Tapos ito, if we input the d over h, then you can get you can simplify this. Magiging 6 pi r squared lang siya. Okay? So if we proceed, we should get something like okay. Tapos si surface area over volume, then therefore ang volume kasi ng isang riser is just 2 pi r cube. So we get 3 over r. Ito yung magiging surface area over volume ng riser. Tapos, since known naman yung volume ng casting natin, then we can just compute it. No? Yung casting kasi natin is just yung volume surface area over volume niya is just equal to length times width plus width times height plus ano bang kulang? Length times height, no? That is the at times 2 lahat, no? Tama? Because you have two surfaces. Kasi rectangular prism to. So this becomes the surface area over the volume, which is equal to volume is just length times width times height. And we already know the dimensions, no? Kasi given naman, it's 25 by 25 by 5. And if you compute that, you should get something like this, no? 0.56 siya. Okay? Now, if you have 0.56, tapos etong surface area over V natin ng riser is 3 over R, then we express the relative volume also in terms of R. So relative volume again is just equal to yung volume ng riser over volume ng casting. Volume ng riser is again 2 pi r cube. That is the volume of a cylinder. So it's 2 pi r cube because ang volume ng cylinder is 2 pi r h, no? And h is equal to 2r at 2 pi r squared h, I mean 2 pi r squared h. Tapos sabi natin yung pinili kasi nating d over h ratio is 1, so therefore h is equal to 2r. So kaya siya naging 2 pi r cube. Okay? So we have 2 pi r cube. Tapos ito, volume of the casting is just length times width times height. Okay? So we have 3125. Tapos input natin yung constants. And from the table given earlier, ito, we have steel daw kasi siya, so we use 10. Sorry. We use 10 0.03, and 1 as the ABC constants. So we have dito, ito siya, 0.1, 0.03, this is A, this is B, and this is C. So set up natin siya, and if you notice, itong Caine equation natin, we have only one unknown, which is the R. Tapos we have one equation with one unknown. So pwede natin siyang i-evaluate, no? So you can actually use just a calculator for this, no? Pwede rin ang gamitin nyo is yung MS Math. Tapos hopefully you get this answer, no? And again, if you look at it, yung highest niya na root is actually, let's try to evaluate no, ano yung highest root. Highest root nito is actually to the fourth, no? Kasi if you look at it, maging r cubed dito, ito 3 over r dito. So, if we multiply all by r, maging r to the fourth. Yun yung highest na degree niya. So, this is of the fourth degree. So, you will have four roots dito, no? So, you need to be very mindful dito, no? You need to be careful and look at which root makes the most sense. So, if it's a negative root, then obviously it doesn't make sense. So, hindi nyo kukunin yung mga lahat ng negative roots. If it's a root that is, for example, may isang root ata dito, I forgot the value nyo, pero something like 150 ata or something. Parang ganyan. If it's 150 yung radius niya, it doesn't make sense because sobrang mas malaki to kaysa yung dimensions ng ano natin, which is just 25 by 25 by 5. Tama? So it's larger, yung 150 is larger than, so parang if you think about it, kung ito yung ano, yung casting mo, yung riser mo, side riser mo, parang ganyan. Mas malaki pa yung riser kaysa yung actual na kinakast mo. Sana nagcast ka na lang ng riser, ano? So yun, pag ganon, kailangan piliin nyo yung the root that makes the most sense. And in this particular case, the radius should be around 6.422. And if you multiply that by 2, because we have a d over h that is equal to 1, then we have a height of 12.844. So again, when it comes to riser design, we always round up, no? Kasi ito kasi yung mako-compute natin na riser design, we give it to the pattern makers. And yung pattern makers, hindi na natin sila papahirapan, no? Kasi kung kunwari bibigyan mo 12.844, gagawa sila ng isang cylinder na 12.844, it's very arduous, no? So just give them 13 cm. So round it up, and if it's a kunwari naka-inches kayo, you give them values that is divisible by ano bang ginagamit nila? I think 1/4 of an inch. So pwedeng ang gawin nyo is kunwari lang inches to so you can give 12 and what's that? 1/4. Pwedeng 12 and 3/4 of an inch. And it's 0.75 lang pala, 3/4. So, but anyway, you get the point class, no? So, if it's in inches, pwedeng per 1/4 inch nyo ibigay para mas madali siyang gawa ng mga pattern makers. If it's in cm, then just give a whole number, no? So it could be 13, pwede ring naka 0.5. That is also a good so pwedeng instead of 7 cm, pwede naman sabihin mo is 6.5 cm. That is already easier to work with than 6.422. Okay, so with the final riser volume equaling to 1664. So ang importante dito when we talk about riser design, no, ito lang actually yung pinaka-importante, ito part na to. So what is the riser diameter and what is the riser height? Okay, so that's Caine method. It uses an empirical equation, and if you notice, okay siya kung kunwari simple lang yung geometry ng mo, pero if you have something like kunwari meron tayong ito yung object natin, no, ganyan, tapos meron siya naka-attach na bar na ganyan kunwari. So sobrang nakakatamad gawin to, no, kasi i-compute mo yung lahat ng volume nito plus volume nito, tapos surface area is a nightmare, no, kasi compute mo lahat ng surfaces, tapos dito, babawasan mo yung surface nito, yung in contact nito. Tapos i-add mo pa yung other surfaces, yung apat na surface around dito, tapos isang surface dito, etc. etc. So it becomes very difficult, no? So the NRL method is actually a simpler method, no? It aims, ang goal, this was developed by the Naval Research Laboratory, and ang goal niya is simplify yung Keynes method. Okay? So instead of using freezing ratio, ang ginagamit nila is what we call as a shape factor, no? This shape factor is just equal to length plus width over thickness, where length is the greater, siya yung greatest dimension, width is the intermediate, tapos thickness natin is the smallest dimension. So if you have something like a 20 by 20 by 20, then length is equal to 20, width 20, and thickness is 20. So yung example kanina, 25 by 25 by 5, these are equal, therefore ito yung length, ito yung width, ito yung thickness. Okay? So if you have something like 30 by 5 by 5, kunwari ganyan, then this is the length, ito yung magiging width, which is also the thickness. No? Okay? So ganyan yung notation when we talk about length, width, and thickness. So the shape factor, gagawin mo is you compute for length plus width plus thickness of what we call as the parent na casting, no? So dito kasi sa sa NRL method, we divide our casting into two groupings, no? So meron tayong tinatawag na parent casting, tapos meron tayong tinatawag na parasite casting. Parasites, or pwede ring appendages, you can call them appendages, or pwede ring parasite castings, no? Okay? So the parent casting is the main casting. Yung mga parasites, sila yung smaller castings that are attached to your parent casting. So sa example ko kanina, yung sabi ko mahirap i-compute, this actually is our parent. Ito yung magiging parent natin. Ito yung magiging appendage natin. Okay? Okay, so let's try an example, no? And we have, before that, meron tayong tinatawag ng mga NRL graphs, no? Ito. This is an example of an NRL graph. So the NRL graph is just a plot of the shape factor on the x-axis. Ito yung shape factor natin. This is our shape factor. This is the shape factor on the x-axis. Tapos, yung sa y-axis natin is the relative volume. So if you can solve for the shape factor, you just use the plot, and this is logarithmic on a logarithmic scale. So we find the tapos extrapolate lang natin, kunwari, interpolate, I mean. So kunwari, we are using gray cast iron. So this is gray iron. Tapos lang natin yung corresponding relative volume. So it becomes easier to use, no? Kasi automatic may relative volume na tayo. And if you remember, relative volume is equal to RC over, to V ng riser over V ng casting. So we just need V ng casting, no? Because if we multiply the casting volume times the relative volume, then we get the volume of the riser. And if we know the D over H ratio, then we can know the dimensions of the final risers that is needed. Tama? So what we need to do is find the shape factor first of the parent casting, then we can find the relative volume, then find the final volume of the casting. But the final volume of the casting is not as simple as just taking the total volume, no? So you will be tempted to say na, kunwari, kanina natin example, na ganyan, hindi ba i-add ko lang to, sir? Ang volume nito plus volume nito, yun yung total volume of the casting. So in the NRL method, we don't, it's not as simple as that, no? So we have what we call as the effective na casting volume. So yung effective casting volume is just equal to the parent volume plus only a percentage of the parasites. So yung parasites natin, meron lang silang only a portion of the of its volume is actually contributing to its overall volume. Para ganun. So as to speak, no? Okay, so the formula becomes the volume of the parent multiply plus a parasitic volume, a percent parasitic volume na factor. We call this as the F value lang, no? Multiplied by the volume of the parasite. Okay, so if you have multiple parasites, then for example, if you have kunwari isa pang parasite dito, then you'll have another F value dito multiplied by the volume of this parasite. Ito, kunwari F1, V1 to. If you have a third one, kunwari dito, then this becomes F3, V3, so on and so on until you reach the final parasite. Okay, so summation siya ng lahat ng F value ng parasite multiplied by the volume of the parasite itself. Okay, so to get the percent F, etong F na to, gagamit tayo ng chart. So ang tawag sa chart na to is the appendage volume calculation chart. So the appendage volume calculation chart looks like this, no? Ito siya. And this is a chart of the thickness ratio versus the F value. So itong nandito, sorry. Okay. So ito, this is your F value. Ito yung percent F natin. Tapos dito is the thickness ratio, which is just given as the thickness of the parasite divided by the thickness of the parent. Okay. So again, medyo na-mention ko to earlier kanina, no? So if you look at this, may iba't ibang line siya depending on what the geometries of the parent and the geometry of the parent and the appendage is. So for example, if it's a bar parent that is feeding a plate appendage, then we use this line. Kung plate naman siya, yung parent, if the parent is a plate and it's feeding a bar, then we use this line. If they have the same geometry, kunwari a bar parent feeding a bar na appendage or a plate parent feeding a plate appendage, then we'll just use this middle line here. Okay? So if you know the thickness ratio, kunwari lang ang thickness ratio niya is a 0.4. Tapos we know that it's a bar feeding bar, kunwari. So a bar parent feeding a bar appendage, then we can say na yung percent parasitic niya is 40%. So yung F value natin, F is equal to 0.4. Okay? So for that particular appendage, multiply natin yung 0.4 times the volume of that parasitic. Okay? So if you have multiple parasitic, then you need to assess yung mga thickness ratio for that parasit, for each of those parasitics, tapos hanapin nyo yung bawat F value ng mga parasitics na yun. Okay? So kaya dito lang medyo tatagal yung NRL method, no? Lalo na pag marami yung mga appendages natin. So maghahanap tayo ng percent F values na. Okay? So let's try this example, no? Okay. Let's try this example. Meron daw tayong 12.5 by 25 by 5 na na object. We don't know yet if it's a bar or a plate. Tapos meron din tayong 10 by 2.5 by 2.5 na object that is attached to the parent. Okay, so as early as now we can assess, no, kung bar ba siya or a plate. Our width here is 12.5, no? Again, width is the intermediate na tawag dito, intermediate dimension. Tapos yung thickness is the smallest na dimension. And again, ang ano natin is dapat the width is less than 3 times the thickness of the bar, or kung greater than, pag ano pala class, no? Ang medyo mali yung sinabi ko kanina. Sabi ko kasi if width is greater than 3, it's a plate. kasama pala yung equals. Tapos yung if width over thickness is less than 3, yun yung bar. Okay? So, eto, 12.5 divided by 5. Anong value yun? This is 2 point something, no? 2.5 ba? It's 2.5. Okay? So, it's less than, this is less than 3. Tama? So, therefore, this is a bar. Tapos ito, the width natin, this is the length. Therefore, ito yung width, which is just equal to the thickness, no? So, it's 2.5 over 2.5, which is definitely less than 3. Then this is also a bar. So, for this particular example, we have a bar feeding a bar. Okay? So, we'll use the... First, we'll compute the shape factor. So, shape factor is just the parent casting, no? So, ang dimension ng parent casting natin is 25 by 12.5 by 5. Therefore, yung length natin is the longest one, 25. Tapos, meron tayong 12.5 na width. This is length plus width over thickness gives us a shape factor of 7.5. And if you look at the NRL graphs for, wait lang, this is hindi pala sinabi kung ano siya, no? Pero, sige, try natin i-solve, no? Ano yung shape factor? 7.5. So, ang nakuha niya is 0.575. 7.5 is somewhere, and again, ito kasi class is a, this is a logarithmic chart. Usually, pag logarithmic, ang good rule of thumb to look at it is, if you have two values, kunwari this is 10 and 20, yung gitna na value niya is not at the center, no? It's somewhere around two-thirds of the way. Parang ganyan. So, somewhere dito. So, if you, tapos kunwari, i-divide mo to, so this is 15. So, if you have 12.5, somewhere two-thirds along the way, 12.5, parang ganyan. So, if you look at this, kunwari ito, 10 and 20, 15 is actually nandito banda. That's just how we estimate yung yung logarithmic charts. So if it's 7.5, then it's somewhere dito. And I think this is gray cast lang ata yung ginamit niya dito. Gray cast iron. So, eto siya. 2.06. Ano bang ginamit? 0.575. Hindi, hanapin natin kung ano yung It's mukhang eto ata. It's carbon steel. Steel siguro yung sample natin, no? Nakalimutan ko lang ilagay ng yung example. I think this is a steel sample. So steel sample, this is the line for copper alloys as well as steel samples. Okay? So ito siya. So again, ang ginawa natin is hanapin natin si 7.5. 7.5, akyat natin. Kung saan siya tumama dito. Tapos ito yung relative volume na. So we estimate that's around 0.575 the relative volume, no? So we have the relative volume. Now we just need the effective volume, no, of the casting. So the effective volume of the casting, to find that, kailangan natin hanapin yung mga F values, no? Kasi again, the effective volume is equal to the volume of the volume of the parent plus yung F value ng parasitic. And in this case, isa lang naman yung parasitic natin, no? So, isa lang yung i-add natin doon sa effective volume. Okay? So, the thickness ratio of the parasitic of the parent is equal to 2.5 over 5 because if we remember, ito yung thickness ng parent, ito yung thickness ng parasite. So, that's 2.5 over 5, which gives us 0.5. So, if we use the chart, yung appendage chart, this is a bar feeding bar, so we'll use the middle line, and we have 0.5. So 0.5 corresponds to 50%. Tama? So if it's 50%, then our F value is equal to 0.5. So our volume of our casting is just equal to the volume of the parent. This is just length times width times thickness or height. No, yeah. Sometimes we use them interchangeably, yung height and thickness na dimension. So length times width times thickness plus 0.5, this is the F1, and yung V1, which is the volume of the parasite, 62.5. So if we add more appendages, then therefore, pwede pa tayo mag-add ng ganyan, no? Kung meron pa tayong more appendages. Pero for this example, isa lang yung appendage, therefore, ito siya. Okay? That is now our effective total volume of the casting. Then we just multiply this by the relative volume, which is 0.575 multiplied by this value, which is this one, and we can find the riser volume. So from the riser volume, if we assume a D to H ratio of 1, which means na yung D natin is equal to H, then we can say na the volume of a riser is just equal to pi over D squared, kasi magiging pi over D squared over 4 times H kasi to. And if it's equal, yung D and H natin, then this becomes pi over D cube over 4. So kaya siya magiging ganyan. Okay? So pi over D cube is equal over 4 is equal to 916, and solving for D, because this is one equation, one unknown, we have that the diameter is equal to the height, which is equal to 10.53, and again we can round it up, no, to make it easier for our pattern maker. So this is 11 cm. So this will be the final risering requirement to ensure that we have a sound casting, and we can also compute for the volume of the riser, no. No, sorry. No need to compute for the volume of the riser because na-solve na pala natin siya. Okay, so in summary, ito yung magiging steps na, no? Just summarize it. Let me just summarize. So Keynes method, number one, first step natin is we always establish D over H ratio muna, no? Kasi kung hindi natin establish si D over H ratio, hindi natin hindi natin simplify into one equation, one unknown, yung JB Caine equation natin. Tama? So kailangan unang-una muna i-establish muna natin yung D to H ratio, which is around 1. Ang general rule of thumb is dapat 1:1 siya or 1:1.5. Yun yung range niya. Okay? So this is to ensure na you have a compact na type of riser as opposed to a tall riser or a short riser. Okay? So we compute for the volumes and the surface areas for both the riser and the casting. For the riser, you will have the unknown values for the either diameter or height or radius, depending on which you are comfortable with. And for the casting, since given naman to, then you can compute for the casting itself, no? Yung mga volume and surface areas na. So from the volume and surface areas, pwede nyo na ma-compute yung freezing ratio. Again, freezing ratio is SA over V ng casting over SA over V ng riser. And again, I like to use volume over surface area ratio. So magiging baliktad siya, volume over surface area ng riser over volume over surface area ng casting, which is analogous to your RV, which is equal to volume ng riser over volume ng casting. So dito nasa taas ang riser, nasa baba ang casting. Again, mas preferred ko to, but if you want, you can also use this one. It will still give you the same final answer, no? Okay, so once you have set up the JB Caine equation, then you make sure to use the correct constant depending on the material you have chosen. And again, itong constants na to, yung A, B, and C, can be found in the tables, no? Okay, so you should have an equation where you are left with only one unknown, And you can either choose, again, pwedeng in terms of R, in terms of D, or in terms of H. I like to use yung diameter, no? Because parang mas madali kasing compute pag naka-diameter na siya. Mas madaling i-relate sa H natin. Pwedeng diameter, pwedeng H. Yung R kasi multiply mo pa by 2 para makuha yung diameter, then multiply by whatever ratio you have. So I like to use in diameter lang. Okay? Then you solve the equation. You solve for the unknown of the equation. Again, this will have multiple roots. As we've discussed, this is of the 4th degree, so dapat 4 roots siya. So we need to choose the one that makes the most sense. So again, all negative roots, automatic, hindi na sila kasama, delete natin sila. Tapos yung medyo masadong malaki naman, hindi natin isasama. So ang isasama natin is yung medyo, yung nag-make sense for the design that we are choosing, no? So dito, this will take some practice, no, on deciding which makes the most sense. So siguro for this case, you can consult with us, no, kami ni Juan, if the route you have chosen makes sense or not. Okay, then this is an optional step. You can always compare it with the NRL method, no, kung same ba kayo ng, or kung in most cases same lang naman ang nakukuha or very similar yung nakukuha ni NRL method and JB Caine. So NRL method is much simpler to use, no? So number one is you establish kung sino yung parent, sino yung parasitic. The parent will always be the tinatawag na, sometimes we call it as the hot mass, no? So kung sino yung pinakamalaking mass, pinakamalaking volume to surface area ratio, siya yung most likely magiging parent natin. Okay, so anything attached to the parent is known as a parasitic, tapos or an appendage. So we calculate the shape factor of the parent, which is just length plus width over thickness, and use NRL graphs, which are available, no? NRL graphs to find the relative volume. Then we determine the geometry of the casting, which is either a bar or a plate, as well of the casting, which includes your parasite and the parent, no? So the parasite and the parent. So establish kung bar ba siya or plate. Tapos compute natin yung thickness ratio so that we can find the F values for all of the appendages. So from these F values, kaya na natin makompute yung effective total volume ng casting, which will be used to solve for the riser volume, no? Okay. So gagamitin natin siya para ma-solve yung riser volume, and when we have the riser volume, we can set the D is to H ratio, and from the D is to H ratio, masasolve na natin tong dimensions, no? So we can solve the diameter, the required diameter, and the required height, the casting. So again, optional, you can compare it with JB Caine's method. Okay? So siguro kung if you want to practice, no, one thing you can do, class, is dun sa example na binigay ko, try to compute yung example for NRL, compute you using JB Caine method. Tapos yung example for JB Caine, compute nyo using NRL method. Tapos tingnan nyo kung similar ba yung values na makukuha nyo. Okay? So I think medyo sakto tayo nag-end, no? We end exactly at 1. Before we end, are there any questions? Madali lang ba? Kaya ba? May nakakalitong part ba sa ano natin? Bakit na-remove si Riquel sa meeting? Sino natanggal kay Riquel? Okay lang? Kaya naman, no? Usually sa exam, saan ba nahihirapan ng mga estudyante? Hindi ko maalala kung usually sa NRL, sa pag-establish ng shape factor, minsan nagkakamali sa pag-determine ng length at width. Tapos minsan yung sa parasitic volume, mali yung nila, yung pag-add ng total volume. Minsan kasi ang ginagawa nila is total volume lang, hindi kino-consider yung percent parasitic. Pero other than that, I think kaya naman siya. Medyo matrabaho lang siya pagka or sometimes unexpected yung amount of work na kailangan nyo palang gawin. Kasi kung titingnan nyo o overview lang, mukha siyang super dali lang. So, minsan yung mga estudyante hindi na nagpa-practice. And when it comes to the exam na, parang medyo complicated pala siya. Tapos doon na nagkakaroon ng issues. Okay? So, okay, sabi ni Rebo, Ox lang daw yung lesson. Okay, that's good to hear. Sa iba ba? May comments pa from the other people in the chat? What can you say about the lesson? Dainty, meron ka bang comments? Nag-lunch na ata ang mga tao. Paulo? Pau, may comments ka about the lesson? Wala. Isa-isayin ko na kayo. No? Geneva, how was the lesson? Okay, nasusundan naman. Good, good. Kurt, kahit muddy points lang, ano yung tingin mo confusing? Okay, that's good. Gab? Wala din si Gab. Ivana? Are you there, Ivana? Okay, so most of you I think follow the lesson, no? So siguro madali na lang siguro yung worksheet para sa inyo, no? Haven't uploaded the worksheet yet, pero i-upload ko siya sometime soon. Tapos medyo mas mahirap yung example, no? And maybe it will require conceptually mas mahirap siya because hindi siya calculation wise hindi mahirap naman. Conceptually para kailangan niyo lang mag-isip na ano na kunwari kailangan ko ba talaga i-solve tong certain value na to? May clues ba from the problem that will aid me in determining kung sound yung casting or not? So yung mga ganun lang. Siguro more conceptual yung hirap or yung difficulty niya. Pero calculations wise, madali lang naman yung ibibigay ko sa worksheet. Okay? By the way, meron bang affected sa typhoon? Meron sa inyong apektuhan? Kumusta naman kayo? Geneva. Okay. Taga saan ka pala, Geneva? Sorry. At yung bahay nyo specifically na apektuhan talaga? Okay, that's good. Mabuti nga nakapasok ka ngayon, no? So may na connectivity. Okay na lahat. Okay, that's good, Geneva. Tapos yung iba, okay naman so far. Wala namang issue. Sige. Medyo stress lang, no? I can feel, kahit ako, nasa stress din ako sa SEM na to. Pero hopefully we can finish strong class, no? So, we take what we can. Tapos, let's try to end the SEM strong. And hopefully next SEM, mas ma-address natin yung mga naging issues natin for this particular SEM. So thank you for coming today, guys. And I hope to see you on Thursday ulit. Thursday, discuss naman natin yung riser location. So, kung pwede sanang i-read nyo in advance din yung module 11.2 no? Para smooth yung discussion natin. Okay? Thank you again. And sir, na-blacklist daw po si Rick yan. Paano na-blacklist? Sino na-blacklist kay Rick yan? Ikaw ba, Juan? Pinlacklist mo si Rick yan? Accidental blacklist. Secret po. Totoo ba? Paano na-blacklist ni Rick? Rick yan? Let's lang kaya na makapasok. In-invite ko si Riquel ulit. Anyway, sige. See you next Thursday class, and thank you again for coming today. Happy eating kung hindi pa kayo nagla-lunch. Okay. Ah, okay, bye-bye guys.